Hey folks, how's it going? Mr. Murray coming to you with a video on rotations in the coordinate plane. Okay, so in this video I'm going to be breaking down a third type of transformation called a rotation, sometimes called a turn. And again, in this video, as with the others, I will break down what it means to rotate points, how we talk about the terminology and notation that we use, and I'll talk about a couple different overall types of rotations, and there'll be problems for me to do as well as ones for you to try. All right, so without further ado, a rotation of a point, line, or shape in the coordinate plane is the movement of that point, line, or shape in a clockwise or counterclockwise direction about a fixed point. Now, nowadays, you're less likely to see actual clocks with hands on them. So if you're someone who only looks at a digital clock, like the clock on your iPhone or smartphone, you may not know what clockwise and counterclockwise means. So if you have a chance to take a look at one of these kinds of, I guess you could consider them old-fashioned now clocks, such as the one in the classroom, look at the direction that the second hand, not hand second, the second hand, that red hand moves, right? That is always moving in the clockwise direction. They all do, but the second hand moves a lot more regularly, right? It moves each second. So when we talk about clockwise, what that literally means is in the direction the clock turns. Okay, so 12, 1, 2, 3, that's clockwise. Counterclockwise means counter means against. So when you think counterclockwise, it means against the direction that the clock turns. So 12, 11, 10, 9. That's the opposite, okay? So I'm really emphasizing that because one of the places that people tend to kind of get a little bit mixed up is knowing the proper direction and the difference between clockwise and counterclockwise. So it's something we're going to be talking about. So as with all transformations, you can see we have a pre-image, what happens before, an image, what happens after, and we sometimes call that fixed point the center of rotation or the point of rotation. All right, you don't always have to rotate around a point. Technically, I believe you might even be able to rotate about something more. We're just going to stick to rotating about a point. So a rotation is considered a rigid motion, as with translations and reflections, because when a shape is moved through a rotation, the distance between any 2 points on or within the shape remains the same before and after the rotation occurs. If you look at the example here, you can see that A and B are the same distance away from each other, for example, in the pre-image and the image. Same with A and C and B and C. Okay, so let's go ahead and take a look at some notation here. And we're going to see how do we talk about rotations. So similarly with reflections, there are two ways to describe rotation. We can talk about a verbal notation. For example, ABC is rotated 180 degrees about the origin. So you notice that there is a measurement, how much, 180 degrees, and I also specify what point I am rotating about, the origin. For those of you who do not know, the origin is the point 0, 0. It is the point where the x and the y axes meet. All right. Now, notice that I didn't specify clockwise versus counterclockwise. You can do that with 180 degrees, and that's because we would not know the difference between clockwise and counterclockwise when you're rotating 180 degrees. Any other amount, you would have to specify which direction, and that's something we'll talk about when we get into more specific examples. There is a coordinate rule for talking about rotations, and we'll see that it's only really about the origin, and that is something that we are going to figure out as we go. So as you see here, again, two types of rotations. Mainly we see about the origin, but we can really rotate about whatever point we want. 2, 1, 3, 3. -1, 2. Really, any point you want, we can really rotate about it, okay? And as you see on the left, we retain this idea of prime notation. So as you can see, we rotated 180 degrees about the the origin here, and you can see that 3, 7a went to -3, -7, a prime. 8, 5 went to -8, -5, and 9, -3 went to -9, 3. So you can think about what kind of rule could we use when we're talking about a 180-degree rotation about the origin. What's happening to the x-coordinate? What is happening to the y-coordinate? Okay, and we'll see more as we go through some kind of specific examples. So without further ado, let's dive into the idea behind how we are going to go about the rotation. So it's a few kind of basic steps. I try to really be as conceptual as possible, and really I don't like to use the rules. So what we're going to do is we're actually going to rotate by physically rotating our paper. So when we're rotating about the origin, what we're going to do is we're going to put our finger on the origin, and that is this point in the center, 0, 0. And what we're going to do is we're going to take our paper and we're going to rotate our actual paper according to the amount and direction of rotation. So as you can see here, I just did a 90-degree clockwise rotation about the origin, 90 degrees in movement, and it's clockwise because you can see that my grid here, right, swung in the direction a clock goes. So you can imagine that little green dot up at the top being 12 o'clock, and now I've moved to 3 o'clock, right? That's going clockwise. If I go from 12 o'clock to 9 o'clock, that is the opposite way that a clock goes. That's counterclockwise. So what happens when you move it is you pretend as though the rotated x-axis, xy-axis that is the actual xy axis, and you write the coordinates of the new point. So what I'm essentially saying is pretend these numbers weren't here, and this was y, and this was x. Forget the numbers. Where does it look like a went to? Well, it looks like a went to 1, 0. If you imagine we're going 1, 2, 3, 4, 5, forget that these are negatives. Forget it entirely. Imagine these numbers weren't even there. A looks like it's at 1, 0. C looks like it's at 4, 0. And B looks like it's at 1, -5. See if you can try to make sense of that and convince yourself about this, right? Again, you're ignoring all of the numbers printed on the original graph, and you're just going off of pretending there were no numbers there at all. Where does it look like it went? Okay, that being said, we're then going to take that was step 2, or rather that was step 3. And now we're going to go ahead and rotate back, reset our paper just as it was before anything happened, as if we'd never done anything at all. And we are going to plot the points that we've just written down. So 1, 0, 4, 0, and 1, -5. Okay, so this is A prime, C prime, and B prime. And just like that, we rotated 90 degrees clockwise about the origin. There was no rules to memorize. All we had to do is literally place our finger on the origin and turn our paper. And what's actually really cool about this is that eventually when we get to the point where we're going to rotate about things that are not the origin, this strategy is actually also going to work. Let's observe some things here. We went from 0, 1 to 1, 0. We went from 0, 4 to 4, 0. And we went from 5, 1 to 1, -5. So we're going to have to think about this. What do we see happening with the coordinates here? Very interesting. Okay, what's going on? All right, okay. So let's look at another example. We're going to go ahead and rotate, again, 90 degrees clockwise about the origin, okay? So we're going to put our finger, pretend you're putting your finger on 0, 0. Okay, we're going to take our point, our plane, and we are going to rotate it 90 degrees, and I promise I'll get it right. There we go. So we've rotated our paper 90 degrees. Now again, we're going to ignore all of the numbers. We're going to pretend like those numbers, and I know it's really, really challenging, but pretend like they were not there, okay? So where does D look like it went to? Okay, so if I look at point D, D appears, right? that it went to a completely different place. So if we pretend that now this is a positive x, this is positive y, this is negative x, and this is negative y, then the point D goes to 3, negative 1. The point E goes to 3, negative 5. So I'm using the numbers as a guide, but I'm remembering to be very careful about my positive and negative signs. F goes to negative 1, negative 7. So this looks positive, but again, these numbers are negative y's, if in this case. And G goes to negative 1, negative 1. Okay, and again, I'm using my little clock tool here to help me out. All right, now I'm done. I have my points. I rotate back, and now I'm going to go ahead and plot my new points. Okay, so D goes to 3, negative 1. E goes to 3, negative 1, 2, 3, 4, 5. F goes to negative 1, negative 7. And G goes to negative 1, negative 1. Okay, so we'll go ahead and reconnect these points. All right, very interesting. So very interesting indeed, and it looks like, again, let's see what we can identify with these patterns here. So we have from 1, 3 to 3, negative 1, 5, 3 to 3, negative 5, 7, negative 1 to negative 1, negative 7, and 1, negative 1 to negative 1, negative 1. So interesting what we have going on here with the flipping of the points, right? All right, and again, I just want to show you. Let's take this line and actually turn it. Ooh. And we might need to do some adjusting on my points here. Whoa. All right. Okay, so again, we can see 3, negative 1, negative 1, negative 1 for G, 3, negative 5 for E, and 3, negative 1. And the reason it doesn't work perfectly is because there is a little bit of shifting there. But that's nothing, it's not going to always, we wouldn't expect it to line up perfectly there. But when we do flip it back, right, you can see it looks just like that shape. All right. So very interesting indeed. Very interesting indeed. So what we have is we got to think about what's going on with the X and the Y's. Right? So to me, it looks like the X and the Y's flip place. So 3, 1, 3, 3, 1, 5, 3, 3, 5, 7, negative 1, negative 1, 7. But there's a little bit more to it. It's not just a matter of flipping. So it's something we're going to have to think about when we think about our rules. We're flipping, but we're doing one thing to one of the numbers. Think about that. All right, let's take a look at another one. So now we're going to go 90 degrees counterclockwise. So again, we put our finger on the origin, and I'm going to turn 90 degrees, so we're going from 12 to 9. We're going against the direction the clock usually goes, and we're going to do the exact same thing. So we have A was at 0, 1. It's going to go to negative 1, 0. So you have to be really careful. So if this was, imagine again, at Y and X, if you didn't have any numbers here at all, and I had just given you this graph, no numbers, just a blank coordinate grid with the shape plotted, A would be at negative 1, 0. B would be at negative 1, 5. And C would be at negative 4, 0. Okay, so I plot my 3 points. Now, you're probably not going to have it this easy. In reality, you're probably going to have to write your points somewhere else, and that's okay. You'll just write them down on the side somewhere just to keep track. And then again, we'll plot negative 1, 0, negative 1, 5, negative 4, 0. And the shape, as you can see, retains that proportionality. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. They're 5 away from each other. Okay, these are 3 away from each other. And then this is down 3 over 5. So all of the distances between the key points and all the points between them remain exactly the same. So we'll label A prime, C prime, B prime. Okay, here's my rotation 90 degrees counterclockwise about the origin. You can also see that if I take a point and connect it to its image, right? Because remember, this is the center of rotation. If I take B and I make a connection between the image of B and the pre-image of B, notice this is a 90-degree angle. Okay, if I do the same thing with C, I could have gone a little bit better. Come on. 90-degree angle, and the same thing with A. Because they're on the same line, I would get a 90-degree angle. So you can see again, between any pre-image point and image point, you're going to have a 90-degree angle because this is a 90-degree rotation. All right, what do we notice about the points? 0, 1 going to -1, 0. 5, 1 going to -1, 5. And 0, 4 going to -4, 0. So notice here we switch places, and here we switch places, right? See the X and the Y flips, 1, 3, 3, 1, kind of. 5, 3, 3, 5, kind of. 7, 1, -1, -1, 7, kind of. Here we also see a flip, but there's a difference, right? Something is being changed about one of the coordinates here. A similar thing is being changed about one of the coordinates here. But the coordinate that we're manipulating, that's kind of the same but not really, is a different coordinate, right? Think about what coordinate is getting something done to it here. And it's not like we're adding or subtracting. It has to do with the signs, okay? So what's happening here versus here? Because the flipping of the X and the Y is still kind of occurring, but it's a little bit different. All right. Now we're going to go 270 degrees clockwise about the origin. So 270 degrees, I put my finger on the origin, which is the center point, right here, my center point. And now I'm going to go 90, 180, 270. But what's interesting is, look, 270 clockwise is the exact same as 90 degrees counterclockwise. So very interestingly, some of these rotations you could do in a couple ways. So one thing we notice, it's equal to the same thing as 90 degrees CW clockwise about the origin. Okay, so it's the exact same thing. So it's worth noting that. All right, let's take a look. We're going 90 degrees clockwise, counterclockwise. So we know what counterclockwise looks like. It looks like these more or less flip, but one of the signs is flipping. Let's see if we get the same thing. So A is going to go, it now looks like it's at -2, +2. B looks like it's at -2, +5. C looks like it's at -5, +5. D looks like it's at -5, +2. Okay, let's take this and go ahead. Let's take this and go ahead and reset it back to the beginning, how we first found it. -2, 2, -2, 5, -5, 5, -5, 2. Now we are going to want to label because this is a square, and squares are kind of odd. So let's see, -2, 2, this is A, -2, 5, -5, 5, -5, 2. Okay, so the points flipped, but what sign changed? It's not a clean flip, right? 5, 5 just doesn't flip to 5, 5. One of the signs gets its coordinates flipped. So which one is that? We got to think about it, okay? Because we're trying to, again, we may want to come up with some rules here to simplify the process. All right, one last one. We're going to go 180 degrees about the origin. Note that I did not specify direction because the directionality does not matter. I am going to have to go ahead on my screen, and I am going to actually need to delete the 4 letters because I just put those there so you could see what was what. Unfortunately, I'm going to have to delete these because, one, they have primes, and some of them honestly shouldn't, but also because the letters are not going to rotate. Okay, so here I go. I'm going to rotate 180 degrees. The way I do it does not matter. It's going to end up in the same place. So if I go 180 clockwise, I end up here. I'll reset. If I go 180 counterclockwise, I end up here. And again, all I'm doing, and you can see it's the same, is I'm just putting my finger on that point of rotation and I'm turning my paper. Okay, and when you're not on the computer, it's actually sometimes a lot more manageable than when you're on the computer. Okay, so notice now this is where it gets difficult because A was at 2, 1. Now A has gone to -2, -1. Okay, A was that bottom point. Okay, B was at 4, 1. Okay, now B has gone to -4, -1. Hopefully you're starting to see the pattern. So think about 5, 4. C was at 5, 4. See where C is. Pause if needed. We rotate. C goes to -5, -4. And remember, you're ignoring the numbers as they're written right now. Pretend like it was just an empty coordinate plane. Nothing was there. And you're just pretending like you just came upon it looking just like it was rotated. And now 1, 4 goes to -1, -4. So we've got our 4 points. Okay, so I'm done. I'll go ahead and reset. Boop. And I'll plot my points. -2, -1, -4, -1, -5, -4, -1, -4. I'll go ahead and use the line tool, make my life a little bit easier. Fortunately, I've got the privilege of being able to do this, whereas you all would have to draw your lines, and I am definitely sensitive to that for sure when I think about how I'm going to evaluate things. So here's my A prime, whereas this was my A. Here's my B prime, whereas this is my B. Here is my C prime, whereas this is my C. And here's D prime, and this was the original point D there. Oh, and these original ones should not have primes on them because those were the pre-image. Okay, and so think about what happened here. What is the difference? Did the points switch? Did the X and the Y switch? Did the sign switch? What happened? Okay. Okay, so let's go ahead and take a look at some rules. Now, the coordinate rules, it's important to note, only work when you rotate about a point that is the origin, meaning 0, 0. When you do not rotate about 0, 0, these rules are no longer guaranteed to work. Though, we can have a strategy that involves 0, 0 when we rotate about points that are not the origin. But again, these rules only work when you rotate about the origin. So, I'm going to show you, again, a rule and the equivalent rule. So when you see 270 degrees counterclockwise, that is the same thing as 90 degrees clockwise. And what we've seen is that xy is going to become y negative x. The points are going to flip places, but as you notice from our example, they flip places, but then the sign of the new y coordinate is flipped from 1 to -1, from 5 to -5, from 7 to -7, from 1 to -1. What about when we rotate 90 degrees counterclockwise? It's a flip of the x and the y, but now which one flips? Which one is changed? It is the original y coordinate. So when we go 90 degrees counterclockwise, it is the y coordinate that changes. Okay. What about when we go 180 degrees? What's happening? Are the x and the y's flipping places? I would say they are not. But what does change is the signs. So xy, we flip the x sign and the y sign. But one thing we didn't look at was 360 degrees. What is going to happen when you take a shape and rotate it 360 degrees? Observe how it's the exact same thing no matter which way you rotate it. And that's because when you rotate 360 degrees, you're taken right back to where you started. It's like you actually rotated 0 degrees or you didn't rotate at all. So when you do a rotation of 360 degrees, you can't even tell because you're taken exactly back to where you've started. All right, so these are 4 rules if you don't want to use the paper turning strategy for how you're going to go ahead and rotate about the point 0, 0. So these are things that I am going to try to make available on the note sheet, and you definitely want to see if you can find these and adapt your note sheet so that you have access to these really important rules. But again, you do not have to use them. The paper turning strategy, whereas you turn your paper, write the points down, turn the paper back, and plot, will allow you to also correctly execute these geometrically without the need to use the algebraic formulas. So we now have a way of approaching it with algebra and geometry. But what about when we don't rotate about the origin, rotating about a non-origin point? So here you can see I'm rotating the same ABC from a couple of examples ago, but now I'm not rotating about the origin. I'm rotating about the point -2, 2. So what we're going to do is we're going to actually apply the same exact principles of rotating about the origin, but there's going to be one little trick. So what you're going to do, as you see in this bottom shape, and I had to do a screenshot so that this would be a nice rotation, what we're going to do is I'm going to specify so there's a more clear example. So we're going to go 90 degrees CW clockwise about the point -2, 2. So what we're going to do is we're going to pretend like -2, 2 is the origin. So we're going to draw a new x and a new y axis through it. And we're going to ignore the entire original x and y axis. We're going to pretend like they're not even there. So what I'm going to do is think about it like this. Originally, in the original system, c is equal to 0, 4. Okay, but we're going to ignore that, and in our new system, c is now actually at 2, 2, because relative to the point of rotation, it's 2 to the right and 2 up. Okay, that's an example. Whereas a used to be at 0, 1, and now it's gone to 2, -1, because from the point of rotation it's 2 over and 1 down. And b was originally at 5, 1, but now relative to this point of rotation it's at 2, 3, 4, 5, 6, 7, -1, because it's 7 to the right and 1 down. So that's where it gets tricky. But here's the thing. We're now going to take our point. We're going to put our finger on this new point, this point of rotation, and we're going to turn our paper 90 degrees, in this case, because we rotated 90 degrees clockwise, about that point of rotation. And what we're going to do down here is we're going to write A prime, B prime, and C prime. But we're going to do it, again, pretending that this red point is the origin. So if this were the origin, A prime is 1 to the left and 2 down, right? It looks like if this was 0, 0, this would be -1, -2. B looks like it would be at -1, 1, 2, 3, 4, 5, 6, 7. Now observe, okay, -1, 7, and sorry, -1, -7, you can actually execute the rules for rotating about the origin, right? Remember, when we go 90 degrees clockwise about the origin, remember what we do? We flip the x and the y, but then we change the sign of the y. That was one of those rules. So we actually are still doing that in a sense. And finally, c goes from originally 2, 2 relative to this point, it goes to 2, -2. So again, we did that flip. Okay, so that is step 3. We're ignoring the original x and y. We're pretending like it's not even there, and we're rewriting the points relative to that central point of rotation. And now I'm going to turn back, and I'm actually going to erase this little purple point here, and I'm going to replot the new shape again with all of the points relative to the to that point of rotation. So I'm just going to erase these, so I've got some room to write, and now I'm going to replot the final points. So this is 0, 0 again, pretending like the point of rotation is 0, 0. I'll actually do it up here. So I'm going to go -1, -2 from the point of rotation, -1, -7, right? 1, 2, 3, 4, 5, 6, 7, and 2, comma, -2. Okay, and then I'll connect. Ooh, let's just undo that and try again. Boom, boom, boom. Now observe, let's go ahead and plot and really mark these up. So -1, -2, that would be A prime, -1, -7, B prime, and C prime. And what this upper shape indicates is, remember step 4, step 5, you're going to erase the original X and Y. So you really do want to do this in pencil, because you're going to erase, not the original that is, you're going to erase the X and the Y that you drew in to assist you with the transformation. Because this was not the actual X and Y axis, right? But it helped you for doing the rotation. So if we look at C, okay, we can see that there actually was a 90-degree angle there. Oh, didn't mean to draw that. Let's back that up. So you can see here's a 90-degree angle. With B, you can see a 90-degree angle between the pre-image and the image. And with A, you can see there's a 90-degree angle between the pre-image and the image. Okay, so it's very, very similar to what we're doing, but there's that one little twist. Okay. All right, so let's take a look at how it would work here. So what we have is we have -2, 1. So I'm going to draw my X and my Y. I'm going to ignore the original X and the Y. I'm going to pretend like this point here is the origin. Pretend throwing that all away for a moment. Okay? So J, if this was the origin, would be at -1, -2, -3, -4, -5, 1, 2, 3. -5, -3. Okay, K is going to be at -1, -2, -2, -3. L, okay, it's even with that. So 0, -1, -2, -3, -4, -5, -6. And M is going to be at -1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. -7, -6. So let's take stock of our original points. Okay, what I'm going to do is I'm now going to rotate. Okay, so I'm going to put my finger on, I'm going to rotate clockwise as if that was the point, right, of rotation. Okay, so we're just going to keep -2, -1. And you would rotate just like that. Okay? So imagine we just rotated about this point. Now, one thing I'm going to do, I'm just going to do a couple little things here so that this is a little bit easier. I'm actually going to take a little bit of a screenshot so we can see this in a little bit better light. Okay, folks, so what I've done is I've gone ahead and taken a screenshot so it's a little bit easier to see the transformation in action, because when I rotate, it's going to move everything. So again, the idea is we want to go 90 degrees clockwise. So we're going to put our finger, we're going to go in the direction the clock turns. Okay? So let's take a look. So J, where has J moved to? New J is at -1, -2, -3, 1, 2, 3, 4, 5. Notice how it moved. -3, 5. They flipped and the Y flipped. So we can literally use the origin rules But we just have to remember that now we're pretending like this point of reflection is that origin. K moved to negative 3, 2. L moved to negative 6, 0. And M moved to negative 6, 7. Okay, so when we flip back, we rotate back, we get that we come back up here. Okay, we're going to replot the points. So negative 1, negative 2, negative 3, 1, 2, 3, 4, 5. Negative 1, negative 2, negative 3, 1, 2. Negative 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. And negative 6, 0. Okay, this is our transformed shape. So we're going to draw in our transformed shape. We're going to get in the practice of labeling. So M prime, J prime, K prime, L prime, and then remember the last step is you're going to delete. You're going to delete those axes so that you're back at the shape that you started with. And we have now successfully done that transformation. So folks, this was a pretty tricky one. If you do need to rewind and take another look, I encourage you to do that. And then in a moment, we're actually going to move on to some ones for you to go ahead and take a stab at. Alright folks, so this video has gone on pretty long and I do have some other examples I could do, but at this point I actually want to move to giving you some ones to try on your own. So I have the shape YKBU. I want you to go ahead and I want you to try to do 3 transformations. I want you to try to rotate it 90 degrees clockwise about the origin, 180 degrees clockwise about the origin, and 270 degrees clockwise about the point 1, negative 1. So please take a moment, pause the video, perform these 3 rotations, and then when you're ready, unpause, and you can see what I got. Alright, here we go. So 90 degrees clockwise about the origin, and I'm actually going to erase in between each one so we don't get too confused here. So 90 degrees clockwise, again, you put your finger on the origin. We turn 90 degrees clockwise, and we're going to write down our points. So y prime equals 3, 1, 2, 3, 4, 3, negative 4. K prime equals 3, negative 5. I'm only just subtracting 1. I kind of could cheat there. I believe that's a B prime. 0, 1, 2, 3, 4. So 0, negative 5. And U prime, negative 2, negative 2. Okay? Or you can use the rules. You can see I'm not going to use those rules, but you're welcome to do those if you'd like. Okay? So again, U 2, 2, negative 2, or 2, negative 2, right? You got the flipping and all those kinds of rules there. So Y, 3, 1, 2, 3, 4. K, 3, negative 5. 0, negative 5. Negative 2, negative 2. Okay. Y, K, B, U. Okay, and we've got Y, K, B, and U. And this is the first of our 3 transformations. All right, now I'm going to go 180 degrees about the origin. So I'm going to clear this one out. And we're going to start with now the same idea, but I'm going to go 180 degrees. 1, 2 flips. Okay, and I am going to have to vary up the points, right? The points are obviously not the same. So let's erase those points, and we will try from scratch. So now, in no particular order, U prime has gone to negative 2, positive 2. B prime has gone to negative 5, 0. K prime has gone to negative 5, negative 3. and y prime has gone to -4, -3. Okay, so you rotate, you take a look at where it appears to be as if I had just come across these, maybe a little bit goofy because it's upside down. Then we flip back to the standard position and we plot -4, -3, -5, -3, -5, 0, -2, 2, and then we proceed to connect. Connect, 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 connect. Label U, B, K, Y. All right, final one. Here we go. So I'm going to go ahead and again clear all this junk out, and we're going to start, and I'm also going to clear out my points. Okay, the last one I'm going to go 270 clockwise about 1, -1. 270 clockwise about 1, -1. So for this one, I am going to draw. Boop. Ooh, 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 ooh. I don't know why my smart notebook likes to be finicky on me. Okay. So here we go. I'll now do a little screenshot because I'm going to do the turn. Fingers crossed. All right, I got my screenshot in here. Let's just, and again, the screenshot, I'm only doing that because I can't just rotate about the point. It's going to be kind of finicky, like I said. So I'll just paste it over here for now. This one's a little bit more easily rotatable. All right, so now 270 clockwise, I'm actually going to go 90 counterclockwise. And again, we're going to pretend that 1, -1 was the origin. So relative to 1, -1, U is at 1, 1. B is at -1, 4. K is at 1, 2, 3, 4, 1, 2, 3, 4. So -4, 4. And Y is at -4, 3. Given that, I'm now going to go back to my original orientation and plot. So -1, 2, 3, 4, 1, 2, 3. This one, this one, this one. And now all I do, I erase my axes because I've done this in pencil, and I connect the 4 points. This one's the tricky one. And label. So -4, 4, -4, 3. And remember, it's not -1, 4 on the original X and Y. It's -1, 4 relative to the point of rotation. That is, it is 1 to the left and 4 up, for example. All right, so folks, hopefully you found this video to be helpful. As just to recap, in this video, that is, we talked about rotations, and that is turning a line, point, or shape about a point or center of rotation by a certain amount of measurement, in this case degrees, in a particular direction, clockwise or counterclockwise. We talked about how they were rigid motions because they maintain the proportionality, that is the distance between any 2 points in or on the shape. We talked about a verbal description, and through a few examples, we're able to find coordinate rules for how we can do this algebraically, right? We developed our method of rotating by placing our finger on the origin and rotating the paper, which we'll see more in class as well. And then we dived into how to do a similar strategy with a point that isn't about the origin. Somewhat more challenging, but with practice, we will master it. All right, so folks, thanks so much again for watching. I really appreciate your persistence through this definitely lengthy video. Thank you very much, folks. Keep up the good work. Stay positive. And remember, you can do it. All right, folks, don't forget to like and subscribe so you can check out my newest videos. Thanks again for watching. Don't forget to love math, and have a wonderful day.